Good morning students, welcome to Konnur online classes. Previous classes we can discussing the concept of probability. Here probability means possibility is there to happen. Possibility is there to happen. Before completing the concept of probability, we can discussing some important concept. Here today we can discussing a new topic is event. Event is a subset of sample space. Event means it is a subset of sample space. Sample space. Event is a subset of sample space. Here sample space means it is a possible result of random experiment. It's a possible result of random experiment. Random experiment means it is an experiment. It satisfies two conditions. One is it is more than one possible outcomes. It is not predicted to outcomes in advance. Here these two. One event more than one possible outcomes ಹೊಂದಿರಬೇಕು. ಜೊತೆಗೆ ಆ ರಿಸಲ್ಟ್ ಅಡ್ವಾನ್ಸ್ ಆಗಿ ನಮಗೆ ಗೊತ್ತಿರಬಾರದು. That type of experiment are called random experiment. Possible result of random experiment are called set of all possible outcomes of random experiment are called sample space. Sample space containing more than one element. Here every element belonging to sample space are called sample point. Here today we can discussing a very important term is event. Event is a subset of sample space. Event is a subset of sample space. For example, we can consider one subset sample space 1, 2, 3, 4, 5, 6. A die is rolled one time. A die is rolled one time. Here consider it's a sample. Outcomes are 1, 2, 3, 4, 5, 6. Here possible result, set of all possible result of random experiment are called sample space. Here set of 1, 2, 3, 4, 5, 6 are the sample space of a die is rolled one time. Here consider the sample space. Here we can take one subset, that is even here consider one event, that is set of all even numbers or even number, that is a equal to 2, 4, 6. Here a is a subset of yes. A is a subset of yes. That's why a is called event of. A is a event. A is a one event because a is the subset of sample space. That's why a is called an event. Event means it is a subset of sample space. Event is a subset of sample space are called event. Here consider one example. A die is rolled one time. We get a sample space S is equal to 1, 2, 3, 4, 5, 6. Consider one event, that is set of all even numbers belonging to that term, that is 2, 4, 6 are the even number concerning the that sample space. Here a is a subset of yes. That's why and a is called event because a is a subset of that sample space. Here null event. Here there is no elements belonging to sample space. Here there is no element occurring. There is no outcomes will come belonging to sample space. Consider one sample space we can take as 1, 2, 3, 4, 5 as well as 6. Here this is a sample space belonging to a die is rolled one time. Here consider an event. A is number occurs more than 7, more than number 7. Number occurs more than number 7. Here up to 6 numbers are there, more than 7 number, there is no option. That is definitely an event is called null event. Null event. Here there is no one outcome will occurring to the required terms. That's why that event is called null event. Sure event. Definitely sure event means sure event is equal to sample space. Sample space. Sample space is called sure event. Whatever occurring, that is a sure event. Here event means it is a subset of a sample space. Event means it is a subset of a sample space. Then null event, then no outcome will occurring to the given term, that is a null event. Sure event is equal to sample space. Then simple event, an event containing only one term. An event containing only one term, that is a simple event. Here for example, consider an event A. Even consider sample space S is equal to 1, 2, 3, 4, 5 and then 6. Here this is a sample space. Consider one event, that is even prime number. Even prime number. Here in this term, even prime number is occurring only, that is 2. Here this is a simple event, only one term occurring in the event, that is A is a subset of S. Definitely it is a event. Only one term containing the event is called sure event. Compound event means an event occurring more than one term, that is even number occurring. Here A is even number 2, 4, 6. 2, 4, 6. 2, 4, 6 are the 2, 4, 6 are the numbers belonging to this term. Even numbers occurring to this term, that is 2, 4, 6. Here it is a compound event. Odd number will be occur, that is B is equal to 1, 3, 5. Here these are the compound event. Exhaustive event. Next one is very important term is exhaustive event. Here exhaustive event means consider an event even and another one E2. Consider next one is E3, so on up to En. I don't know how many events are there in our experiment. E1, E2, E3, so on up to En events. Union of all these events, we get a sample space, that is an exhaustive event. They are called exhaustive event. Then finally mutually exclusive event. Mutually exclusive event means consider E1 is one event, E2 is another event. E1 is one E1 is one event, E2 is another event. Here intersection of these two events, we get null set then definitely these two events are called mutually exclusive event. Mutually exclusive event. E1 and E2 are the two events. E1 and E2 are the two events. Then intersection of these two events are called intersection of these two events is equal to null set. Then definitely E1 and E2 are called mutually exclusive events. Here last one is complementary events. That is complementary event defined as mentioned as E bar. Complementary event, that is E bar. Here consider one sample space, that is 1, 2, 3, 4, 5 and 6. Consider one event E is equal to even number occurring, that is 1, 2, 3, even number occurring 2, 4, 6, 2, 4, 6. Then find the complementary event of this one is E bar. E bar. E bar. Here E bar is equal to sample space minus E. Sample space minus E. Here E bar is equal to sample space 1, 2, 3, 4, 5, 6. Then minus even number, that is 2, 4, 6. Definitely complementary event of this much is 1, 3, 5 is called complementary event is denoted as 1, 3, 5. Very important note is here sample space is equal to E union of E bar. E union of E bar. Here S is equal to 1, 2, 3, 4, 5, then 6 is equal to here 1, 2, 4, 6 union of 1, 3, 5. Then definitely union of these two terms we get here event and a complementary of that event is equal to sample. Here union of event and complementary term of that event is equal to sample space. Here event means it is a subset of sample space. Event means it is a subset of sample space. Consider one sample space. Take a set of all even numbers. A is equal to 2, 4, 6. A is a subset of sample space. Then definitely A is called event. Null event. There is no term occurring in the outcomes. That's why we can call as null event. Sure event. Sure event means it is a sure event is equal to sample space. Then simple event means occurring only one term. Compound events more than one term. Exhaustive event E1, E2, E3. So union of these terms we get sample space. Then mutually exclusive E1 and E2 are two events. Intersection of those two events is equal to null set. Then that events E1 and E2 are called mutually exclusive event. Complementary events. Consider one sample space belongings to that one. We consider one event that is even number occurrings to the corresponding sample space. Then 2, 4, 6. 2, 4, 6 are the even number occurring to the that sample space. To find the complementary of that one is complementary of that event E bar is equal to S minus of E. Definitely we get 1, 3, 5. Here S is equal to event E and union of E bar is equal to sample space. Here this is the basic concept of event.